Hey YouTube, another video, and this time I'm going to show you how to drive a unipolar stepping motor. Now this video is not really about how to drive the stepping motor because I've covered this in a previous video, but this is more to sum up the entire subject of stepping motors, how to control them, how to drive them, how the phase excitations work. And in this example I'm using an L297D and an L298N chips. This is the L298 is a dual full bridge, and the L297 is a dedicated stepping motor controller. Before we go any further explaining what we have here in the circuit, I'm going to turn the circuit on and we're going to see what happens with this motor and how it behaves, and then I'm going to explain about it. I'm just going to turn it on for a few seconds because the L298 gets hot pretty fast, and it requires a heatsink, and if we leave it on it will eventually either damage the breadboard here or it will damage the chip or both. Let's see how it works. I'm going to turn the circuit on, and the first thing that you will see is that the motor drives a little bit in one direction, and once the logic unit here resets, it will start going into a cycle where it drives 48 steps in one direction and then 48 steps in a opposite direction. Not steps, but actually full cycles, so an entire full cycle of the phases. So I turn it on and you can see what happens here. So here you can see when it's switching sides, and this is the way it works. There are no microcontrollers here, and nothing that is programmable by code. Everything is just transistor logic. What we have in the circuit, as I said, is the L297 and the L298. The circuit that connects them together is pretty much the circuit that you can find in the data sheet, which is the manufacturer's way of showing how to apply these two together to create a stepping motor controller. And other than that, I've added a 555 timer, which provides a clock to the L297. On each clock cycle, the L297 carries out one step, and we also control the speed of the stepping motor. So you can see that I can pretty much lower it or set it faster. Voltage regulator drops from 12 to 5. This motor is a 24 volt one, but I don't have a 24 volt power supply, but it will do for this example. Here we have a logic circuit which I've built. The logic circuit is what actually makes it go from one direction to another, and also counting the steps. It's made out of two LS163 binary counters. It has a quad AND gate where we're using only a single gate, and it has a flip-flop here which turns the direction of the motor. And what happens here is that the counters are counting. I wanted to turn the motor's direction exactly once we have made 48 full cycles. So that means that the counter here, the main counter, needs to count 3 times 16. So it will count 16, and then this counter will go high. And to know that we counted 3 times 16, which is 48, I've added an AND gate here. So that means that when bit number 1 and 2 on the second counter are high, that means that we've counted 3 cycles of this counter here, and then it gives a high to the flip-flop, and that in turn gives a high to the direction change on the L297. There are four LEDs which I've added here also. They are connected to each one of the coils, and here we have another LED which is connected to the home sensor on the L297. The home sensor indicates when a full cycle has been reached, and to show you that, I'm just going to replace this capacitor right here on the clock so that we can go a little bit slower. Once I turn the circuit on, you will see exactly the 2-2 phase excitation. So you can see here that the L297 is exciting the coils, but in any given time, 2 coils are always on. And here you can see that once we reach 0101, the home sensor goes low. So I'm going to turn the circuit off again. Now I'm going to change the half full pin on the L297. Instead of providing it with a low, which gives us 2-2, I'm going to provide it with a high, and it will give us a 2-1 phase excitation. And then what you will see is that one step has 2 coils are excited, and the next step will be only a single coil. So it gives us, in fact, another half step, and this gives more torque to the motor. So you can see here that it goes, and one time it has 2 coils excited, and the next time it has just a single coil excited. And the final mode that we can drive the L297 and control the stepping motor is by doing just 1-1 phase excitation, and that happens when we connect the half full sensor to the home position, and you will see that we just get a 1-1 phase excitation. So we have only 1 coil that is excited at each time. This is a 2-2 phase stepping motor, so it doesn't drive really efficiently like that. Also, when we're using 1-1, we're eliminating the home sensor, so we don't have the counting functionality anymore, and that means that it will just drive in a single direction, whatever the flip-flop here was left the last time we turn it on. And that's about it. To explain a little bit more about the logic unit. So again, the logic unit, there we go. So the logic unit, again, it counts 48 times that the home position has been reached. And once it reaches 48, so that means that we have 1100, so 2 bits are on high. The 2 high bits go to the AND gate. The AND gate goes high, and that in turn turns on the flip-flop in a different direction. Another thing that I need to mention is that this circuit that I've built here, it has a flaw in it. The flaw comes first of all from the clock. It's not the most efficient clock that you can use, and also I didn't have the correct diodes to use. I just used these 1N4148, and also I'm lacking some values in the resistors. According to the circuit that is described in the data sheet, you need to provide lows to the sensing outputs of the L298, and it should be a maximum of 0.5 ohms, but the lowest value that I have in resistors is 10 ohms. So to get the best results here, I've added I've made 2 arrays, each one made up of 4 10 ohm resistors in parallel, so that gives me at least 2.5, and that makes the motor behave more or less like it should behave, but you should use the exact values described in the circuit. That's it. I think I covered everything, and yeah, if you like this video, then please subscribe to my channel. That always encourages me to make more videos. And if you have any questions, feel free to leave a comment or go to the website. You can contact me directly if you need help with anything, a project or whatever. And that's it. I thank you for watching, and I'll see you next time.